Good morning, children. In the last class, we have discussed about relative atomic mass, percentage composition, how to calculate the percentage composition, and then we discussed about gram atomic mass, gram molecular mass, what is meant by formula mass, finally mole constant. These things we discussed, isn't it? This class, we are going to discuss about two things. One is about the molecular formula and another one is the empirical formula, right? So first one, molecular formula. Molecular formula, it is also known as chemical formula, right? Molecular formula of a compound is a simple notation of a molecule of the elements, various elements which is present in the molecule of a compound, right? In simple words, molecular formula is used to know how many atoms of the elements are present in the molecule of a particular compound. This is known as molecular formula, right? Let us see the definition of molecular formula now. So, molecular formula means the formula which gives the actual number of atoms. Okay, the formula which gives the actual number of atoms of various elements present in the molecule of a compound. This line is very important. The formula which gives the actual number of atoms. Okay, so molecular formula is used to know how many atoms of the elements are present in the molecule of a compound. It is also known as chemical formula. Next one is empirical formula. What is meant by empirical formula? The formula which gives the simplest whole number ratio. This line is very important. Simplest whole number ratio of atoms of the various elements present in the molecule of the compound. Okay. So once again I repeat, empirical formula means the formula which gives the simplest whole number ratio of atoms of the various elements present in the molecule of the compound. In simple words, empirical formula, if you simplify this formula, then you will get the empirical formula. Okay. So if the formula is simplified, then we can say it is an empirical formula, right? So now you know the difference between molecular formula and empirical formula, isn't it? Both are not same, both are different, right? Okay. Now look at this table. Compound is given, molecular formula as well as its empirical formula is given, right? So some compounds are given, see butane, octane, decane, benzene. So these are nothing but organic compounds. Okay, these are nothing but organic compounds. What is meant by organic compounds? Compounds which contain carbon are called organic compounds. Okay, compounds which contain carbon are called organic compounds. So see the butane compound. This is butane. What is the molecular formula of butane? The molecular formula of butane is C4H10. Okay, molecular formula of butane is C4H10 and its empirical formula is C2H5. Already I told you, if the formula is simplified, then it is empirical formula. If you simplify this molecular formula, you will be getting the empirical formula, right? Next one is octane, right? Second one is octane. Its molecular formula is C8H18. C represents carbon element, whereas H represents hydrogen element, right? Okay. What is the empirical formula of octane? Empirical formula is C4H9. Just to simplify this molecular formula, you will be getting the empirical formula. Next one is decane. The molecular formula of decane is C10H22. So its empirical formula So the empirical formula is CH2O. CH2O. Next one is phosphorus pentoxide. Its molecular formula is P4O10, whereas its empirical formula is P2O5. You will be getting 1 mark. Okay, you can expect this in 1 mark type questions, right? So compound name will be given to you. You will be asked to find out whether molecular formula or empirical formula. So these are all very important 1 mark questions, right? Next, to calculate the molecular formula, we have to use one formula, that is molecular formula is equal to empirical formula into n. Okay, n is equal to 1, 2, 3, like that you will be getting values, right? So how to calculate the molecular formula? Molecular formula is equal to empirical formula into n. By applying this, you will be getting the molecular formula. Molecular formula is always the whole number ratio, right? See, based on this, we will solve one problem now. Okay. See, an acid found in tamarinds on analysis shows the following percentage composition. Okay. An acid found in tamarinds on analysis shows the following composition. Percentage will be given to you. So what is given? 32% of carbon, 4% hydrogen, as well as 64% oxygen is given. What do you have to do? You have to calculate the empirical formula. That's the question. Okay. You have to find out the empirical formula of the compound. Okay. So for that, what you have to do? You have to put a long table like this. Okay. And segregate into 7 columns. First column you mention the element. Okay. Element is given in the question. So mention first one is element. Second one you have to write the symbol of that particular element. Third column is percentage. You can convert it into grams also. Next one is atomic mass. Atomic mass you should know for the first 20 elements in the periodic table, right? Next one is relative number of moles. Next one, simple ratio of moles you have to calculate. Finally, simplest whole number ratio. By knowing this, you will be getting the empirical formula. Okay. So in the first column, already I told you, you have to mention the element. It is given in the question itself, isn't it? What are the elements are given? One is carbon, second one is hydrogen, and third one is oxygen, isn't it? So mention area carbon, hydrogen, oxygen. In the next column, what you have to do? You have to write the symbol of that element, isn't it? What is the symbol of carbon? It is C. What is the symbol of hydrogen? It is H. And symbol of oxygen? O. Right? Next one, you have to mention the percentage. What percentage is given? For carbon, what is the percentage given? It is 32%. Okay. So 32%. Next one for hydrogen, 4%. And next one oxygen, 64%. All these first 3 columns it is given in the question itself, isn't it? So you have to copy down from the question. Next column is atomic mass. Already I told you, you have to learn the first 20 elements atomic mass. It is given in the periodic table chart. Okay. So what is the atomic mass of carbon? The atomic mass of carbon is 12. What is the atomic mass of hydrogen? It is 1. What is the atomic mass of oxygen? It is 16. Okay. Right. Next step, what you have to do? Relative number of moles you have to find out. Right. For that, what you have to do? You have to, by calculating the percentage, okay, by calculating the percentage, you need the percentage as well as atomic mass. If you divide the percentage by atomic mass, you can know the relative number of moles. Okay, so what is the percentage it is given? It is given 32. Divided by, what is the atomic mass of carbon? The atomic mass of carbon is 12. So 32 divided by 12, you will be getting 2.66. Okay. Next one for hydrogen also you have to do. What is the percentage given? It is 4. Divided by, what is the atomic mass? getting the value 4. Okay. So like that you have to calculate the relative number of moles. Clear? Shall we move to the next one? Right. So next one is simple ratio of moles. Next we have to calculate the simple ratio of moles. For that, first what you have to do, you have to find out the lowest value here. Okay, among these three values, which is the lowest value? The lowest value is 2.66, isn't it? You have to divide the lowest value with this relative number of moles. Okay, so the relative number of moles of for carbon is 2.66. So 2.66 divided by the lowest value is 2.66, isn't it? So divided by 2.66. Not only for this one, for all the elements you have to divide the relative atomic mass with the lowest value. Okay, lowest value is 2.66. So you have to divide all this, not only for carbon, even for hydrogen, oxygen also you have to take the lowest value, right? So 2.66 divided by 2.66, you will be getting 1, isn't it? Next one we can calculate for hydrogen. For hydrogen, what is the relative atomic mass? The relative atomic mass is 4, isn't it? Divided by the lowest value. What is the lowest value? It is 2.66. So 4 divided by 2.66, ordinary division, just put the decimal point, right? So you will be getting 1.5. The value is 1.5. Next one for oxygen. Next we can calculate for oxygen. What is the relative number of moles? The relative number of moles is 4. Divided by what is the lowest value here? The lowest value is 2.66. So 4 divided by 2.66 is equal to, you will be getting 1.5. Okay. So already I told you, you have to take the whole number, isn't it? Simplest whole number ratio only you have to take. So here 1.5 is given. What is the simplest whole number? The whole number ratio, it will be 3. Okay. So you have to mention 3. Not only here, for all these values you have to change it, right? Here 1. So what is the simplest whole number ratio? It is 2. For 1.5, it will be 3. And here also 1.5. So you will be getting 3. So this is the simplest whole number ratio. Finished, isn't it? Next what we have to do? We have to calculate the empirical formula. That's given in the question, isn't it? Find the empirical formula of the compound. So for carbon, see what is the simplest whole number ratio? It is 2, isn't it? So C2. C2. Next one for hydrogen. What is the simplest whole number ratio? It is 3, isn't it? So put H3. Next, for oxygen, what is the simplest whole number ratio? It is 3. So O3. Therefore, the empirical formula is, you have to mention this line also. Therefore, the empirical formula is C2H3O3. You have to highlight the empirical formula like this. Okay. So once again I will tell you. First you have to mention the element. Second one symbol. Third one percentage. You can convert it into grams also. Next one atomic mass column. Next we have to find out the relative number of moles. Okay. For that how will you do? You have to divide the percentage composition by its atomic number. Particular element atomic number. You will be getting the relative number of moles. Okay. Next step, simple ratio of moles. For that you have to divide the relative number of moles by its lowest value. You have to take the lowest value among this. Okay. By that lowest value you have to divide it. You will be getting the simple ratio of moles. Next you have to convert it into, the final column is you have to convert it into simplest whole number ratio. Right. Finally you have to mention, therefore the empirical formula is, for carbon it is 2, C2. For hydrogen it is 3, H3. And for oxygen it is 3, O3. And highlight the compound. This is the empirical formula of this compound. Got it, children? In this manner you have to work out. Got it? So we can move to the second one. So what is the question here? 20%. If the molecular mass is 30, then calculate its molecular formula. First, what you have to do? You have to put the table like this, right? First, you have to mention the element. Second is symbol. Next, percentage. Next one is atomic mass. Next, you have to find out the relative number of moles. Next, you have to take the simple ratio of moles. Finally, convert it into simplest whole number, right? So, what are the elements that are given in the question? Carbon as well as hydrogen, isn't it? So, mention the element carbon, hydrogen. What is the symbol of carbon? It is C. What is the symbol of hydrogen? It is H. What is the percentage given for carbon? It is 80%. So, put the percentage 80. For hydrogen, how many percentage? 20%. Mention the percentage here, right? Next, what you have to do? You have to find out the atomic mass of carbon as well as hydrogen. For carbon, its atomic mass is 12, and for hydrogen, its atomic mass is 1. Okay, so these four columns, no problem. Next, come to relative number of moles. What I told you, you have to divide the percentage by its atomic mass. Okay. By dividing this, you will be getting the relative number of moles. So, what is the percentage given? It is given 80. What is the atomic mass? Atomic mass is 12. So, 80 divided by 12, this is equal to, you will be getting the answer 6.66, right? So, next one is, what you have to do? Next one, you have to calculate for hydrogen. For hydrogen, its atomic mass is 1. Percentage given is 20, isn't it? So 20 divided by 1, you will be getting the answer 20. Next, what step? Simple ratio of moles we have to identify, isn't it? For that, what I told you, you have to take the lowest digit. Okay, 20 as well as 6.66 is given. So which is the lowest digit? It is 6.66 only, isn't it? So divide 6.66 divided by the lowest digit is 8 only. So if you divide this, you will be getting the answer 1. Next one is, put the value relative number of moles is 20 divided by the lowest digit is 6.66. You will be getting 3, right? So now you know the simple ratio of moles also you know. Next step, the simplest whole number ratio is given in the whole number only, isn't it? So just put the number 1 as well as 3. Okay, now this one clear. Next, what you have to do? You have to first of all you have to find out the empirical formula, right? So the empirical formula is for carbon. Okay, what is the simplest whole number ratio? It is 1. C1. For 1, no need to put. Okay, just to keep it in your mind. For hydrogen, it is 3. So H3. So what is the empirical formula? The quantities no need to put here. The empirical formula is CH3. Carbon 1 as well as for hydrogen 3. Okay, so CH3 empirical formula. We got the empirical formula now. Next, what you have to calculate? You have to calculate the molecular formula, isn't it? For that, we have to use this formula. So, empirical formula mass. First of all, you have to find out the empirical formula mass. Okay, how will you find out the empirical formula mass? So, your atomic mass already you know, isn't it? If you multiply the atomic mass with its simplest whole number ratio, that is empirical mass, you will be getting, by adding them, you will be getting the empirical formula mass. Once again, I will tell you, empirical formula mass you have to calculate. For that, you have to take the atomic mass, multiply this atomic mass by its simplest ratio, and if you add this, then you will be getting the empirical formula mass. For example, 12. It is given for carbon, isn't it? So 12 into, what is the simplest whole number ratio? It is 1, isn't it? Plus, why plus? Because both carbon and hydrogen only combines here, isn't it? So we have to add. Plus, what is the atomic mass of hydrogen? It is 1. And what is the simplest whole number ratio? It is 3, right? So 12 plus 1 will be getting formula mass, 15 is the empirical formula mass, right? Next what you have to do, you have to find out the n value. Then what is you can calculate it for? Calculate the molecular mass. Okay. So for n, to calculate n, we have to use this formula. N is equal to molecular mass by empirical formula mass. Okay. N is equal to molecular mass by empirical formula mass. What is the molecular mass is given? It is given in the question itself, 30, isn't it? So molecular mass 30 divided by empirical formula mass. So this is the empirical formula mass 15. 30 divided by 15, you will be getting the answer 2. So now you know the n value also. You know the empirical formula. You know the n value. By using this, we are going to calculate the molecular formula, right? So next step is molecular formula is equal to empirical formula into 2. Okay, so this is the formula we have to use to calculate the molecular formula. Molecular formula is equal to empirical formula into 2. Okay, what is the empirical formula? The empirical formula already we know. The CH3 is the empirical formula, isn't it? So put CH3. Empirical formula into 2. The empirical formula is CH3. Put CH3 into 2. Okay, so n value is equal to 2, isn't it? Into 2, right? If you multiply these two, you will be getting the molecular mass, right? C into 2. So you will be getting 2 carbon atoms into H3, right? Hydrogen 3 atoms are here. You have to multiply it with 2. So H3 into 2, you will be getting answer H6. So C into 2, you are getting C2. H3 into 2, you are getting H6. So this is the molecular formula. In this manner, you have to find out the molecular formula, right? Once again, I tell you, you know about this tablet columns, isn't it? First, you have to mention, you have to find out the empirical formula. The empirical formula is for carbon it is 1, so put C, and for hydrogen it is 3, so put CH3. You know the empirical formula. Next, we have to calculate the empirical formula mass, right? So for that, you have to calculate the atomic mass. Okay, you have to multiply the atomic mass with the simplest whole number ratio, and by adding them, you will be getting the empirical formula mass. So the empirical formula mass is 15, right? Next, you have to calculate the n. For n is equal to molecular mass by empirical formula mass. Molecular mass is given in the question, that is 30 divided by what is the empirical formula mass? It is 15. So 30 divided by 15, you will be getting 2. This is the n value known, right? Finally, what they asked in the question, calculate its molecular formula, isn't it? So molecular formula is equal to empirical formula into 2, right? Into n, or otherwise get it into n, right? So this is the empirical formula CH3. What is the n value? N value is 2, right? So CH3 into 2, the answer is C2H6. Okay, in this manner you have to calculate the molecular formula, right? Let me see one more example. See the question. An organic compound on analysis gave the following data. Carbon 57.82%, for hydrogen 3.6%, and the rest is oxygen. What do you understand from this? And the rest is oxygen means it is for 100%, isn't it? For carbon and hydrogen is given. The remaining we have to calculate for oxygen. The remaining percentage will come under oxygen, right? So its vapor density is 83. Vapor density is nothing but the density of gas with that of hydrogen. Okay, with respect to hydrogen gas. Okay. Vapor density is nothing but the density of the gas with respect with hydrogen gas, right? So its vapor density is given. What is the vapor density value is given? It is 83 is given. So what you have to find out? You have to find its empirical and molecular formula, right? So here in the first problem we calculate the molecular formula. Okay, you are carbon, hydrogen. Remaining element oxygen. Third one is oxygen, isn't it? So you mention the element. Next you put the symbol. Next percentage is given. For carbon it is given in the question itself. 57.82%. And for hydrogen it is given 3.6%. Right? The remaining, okay, the remaining is 38. This is not directly given in the question. You have to calculate from these two. Okay, if you add these two and if you subtract with 100, you will be getting this value 38.58. So oxygen value you have to mention it. Next, what you have to do? You have to find out the atomic mass of carbon, hydrogen, and oxygen. For carbon it is 12. For hydrogen it is 1. And for oxygen it is 16, right? So next step what you have to do, you have to calculate the relative number of moles, isn't it? So what is the percentage is given for carbon? 57.82 divided by what is the atomic mass of hydrogen? Atomic mass of carbon it is 12. So 57.82 divided by 12, you will be getting 4.80. Okay, after decimal 2 points you have to take 4.80. Next one is for hydrogen. What is the percentage given? 3.60%. And what is the atomic mass of hydrogen? It is 1, isn't it? So 3.60 divided by 1, you will be getting 3.60. Next one is oxygen. Value is 38.58. Atomic mass is 16. So divide this 38.58 divided by atomic mass 16. You will be getting 2.40. Okay. Next, what you have to do? You have to find out the lowest value, minimum value. Okay. So among these three, which is the lowest value? This is the lowest ratio. Lowest ratio you have to find out. So this is the lowest ratio among these three, isn't it? So next, what you have to do? Divide the relative number of moles divided by the lowest ratio. The relative number of moles is 4.80 for carbon, isn't it? Divided by the lowest ratio is 2.40. If you divide this, you will be getting 2. Next one for hydrogen, the relative number of moles is 3.60 divided by the lowest ratio 2.40. So you will be getting 1.5. Next one is 2.40 for oxygen. Divide this by the lowest value, the same value, you will be getting the answer 1. Finally, what you have to do, you have to take the simplest whole number ratio, okay? So, here the simple ratio of moles is 2. So, whole number ratio means you have to mention 4. Next, for 1.5 you will come 3. And for 1, you will be getting 2. So, what is the next step? You have to find out the empirical formula, okay? So, empirical formula is for carbon. Okay, otherwise you can take the symbol also. For carbon, it is 4, C4. For hydrogen, it is 3. Simplest whole number ratio is 3, H3. For oxygen, simplest whole number ratio is 2. So, O2. C4, the empirical formula is C4H3O2. You have to highlight the empirical formula. Okay. Shall we move to the next step? Right. Next, you have to find out the empirical formula mass. Right. So, second step is you have to find out the empirical formula mass. Right. So, what is the atomic mass of carbon? It is 12. What is the simplest whole number ratio you got? 4. It is 4, isn't it? So 12 into 4 plus what is the hydrogen atomic mass? It is 1. 1 into what is the simplest whole number ratio? It is 3 plus for oxygen what is the atomic mass? 16 and what is the simplest whole number ratio? It is 2. Right? Next step 12 into 4 you will be getting 48. 1 into 3 3 plus 16 into 2 you will be getting 32. If you add these two, you get 83. Okay, you get 83. Right. So what is the vapor density is given? Vapor density is given. The question 83. Right. Next step, what you have to do? You have to find out the molecular mass. So molecular mass is equal to 2 into vapor density. Okay, 2 into vapor density. So 2. What is the vapor know the empirical formula mass. If you divide this, you will be getting, if you substitute this, you will be getting the what? N value, isn't it? So molecular mass is 166. N is equal to molecular mass by empirical formula mass. So molecular mass is equal to 166. So this is the molecular formula mass divided by empirical formula mass. What's the empirical formula mass we got? 83, isn't it? So 166 divided by 83, you will be getting the N value 2. Okay, next step what you have to do? Molecular formula is equal to empirical formula into N, right? So molecular formula is equal to, what is the empirical formula? The empirical formula is C4H3O2, right? Into N value. What is the N value? N value is 2. So C4H3O2 into 2, you will be getting, if you multiply this 2 with this carbon, hydrogen, oxygen atoms, you will be getting the final answer, right? So C4 into 2, the answer is CH. H3 into 2, H6. Next O2 into 2, you will be getting O4. So you know the molecular formula also, empirical formula also you find out, isn't it? So in this manner you have to calculate. For some questions you will be asked to find out only the empirical formula. Okay. So see this question, you have to calculate both empirical formula as well as molecular formula. So these formulas are very important, children. At the same time, you should know the first 20 elements atomic number thoroughly. Without atomic number, you cannot solve the problems, solve these type of problems. Okay. So learn the first 20 atomic mass of the first 20 elements atomic mass is very important. Okay. Without that, you cannot calculate. So in this manner, you have to work out the problems. Okay. Formula is very important. First, read the question twice. You have to find out only the empirical formula means it is enough. The next question, if you are asked to find out both empirical formula as well as molecular formula means first you mention the empirical formula. After applying this, you mention the empirical formula. Next, what you have to do? You have to calculate the empirical formula mass. Okay. Next, you have to calculate the N value. Finally, you have to calculate you have to apply the formula for molecular. How to calculate the molecular formula? Okay. So these things, this type of questions you can expect. You may expect it detailed answer, 5 more questions. Okay. Also, it will take some more time, but before that, you should try to complete. So practice is very essential for this type of problems, right, children? Okay. You will get the assignment, so complete the assignment and send it to WhatsApp group. The remaining things you will see in the next video. Thank you, children. Density. Density is mass by volume, right? So density is defined as the ratio between mass and volume. Okay, density is defined as the ratio between mass and volume. There are two types of density. One is absolute density and another one is relative density or vapor density. Okay, what are the two types of density? One is absolute density, another one is the relative density or vapor density. For solids and liquids, the formula of absolute density is mass by volume. Okay, this is for solids and liquids. Absolute density formula is mass by volume. Whereas relative density or vapor density, the formula is density of the substance with that of water divided by density of water at 4 degrees Celsius. Right? For gases, the absolute density, that is M by V. M represents mass whereas V is volume, right? So, Absolute density is equal to Pm by RT. Pm by RT. P is the pressure of the gas, whereas M is the molecular weight of the gas. Okay. R is the gas constant, whereas T is the temperature. For specifically, we have to mention the formula, especially for solids as well as for liquids. Okay. For solids and liquids, you have to use mass by volume formula. At the same time, for relative density, the relative density for gases, the absolute density m by v is equal to Pm by RT. Okay, you have to mention what is P, what is M, what is R and T. You have to mention it, right? Next one is relative density or vapor density. This one already we have discussed in the empirical formula videos, isn't it? So, relative density or vapor density is defined as the density of the gas with respect to hydrogen gas at the same temperature and pressure. So this is very important with respect to hydrogen gas. Relative density or vapor density is defined as the density of the gas with respect to hydrogen gas at the same temperature and pressure. This is relative density or vapor density, right? So vapor density is equal to M gas. M gas means mass of gas by MH2, mass of hydrogen. H2 is hydrogen, right? So vapor density is equal to mass of gas divided by what is the atomic mass of hydrogen? The atomic mass of hydrogen is 1. Okay, how many hydrogen atoms are here? 2 hydrogen atoms are here. So 2. So vapor density is equal to mass of gas by 2, right? Next one, take this mass of gas on the left hand side. Mass of gas is equal to 2 into vapor density. So this formula we have to use for applying the relative density or vapor density, right? Next we can move to chemical equations. Okay, chemical equations. Chemical equation is a symbolic representation of chemical equation by using symbols and formula, right? There are two parts in the chemical. While writing the chemical equation, there are two parts. One is the product and another one is the reactant. Product, what is the difference between reactant and product? Actually, reactants are substances that take part in the chemical reaction, whereas products are substances that are consumed in the chemical reaction. That is the difference between reactant and product. Okay, so chemical equation is a symbolic representation of chemical reaction by using formula or symbols. There are two parts in chemical equation. One is the product, another one is the reactant. Reactants are substances that take part in the chemical reaction, whereas products are substances that are consumed in the chemical reaction. So, reactants gives product. Got it? Right. See the definition for chemical equations. Chemical equation is a representation of the chemical change in terms of symbols and formula of the reactants and products. Okay, we will take the symbols as well as formula for this reactants and products during chemical reaction. Okay, we will mention it by using symbols or formula. Right. So next one is skeleton equation. What is meant by skeleton equation? Skeleton equation means it is an unbalanced equation. Already we learnt in the first video, according to law of conservation of mass. According to law of conservation of mass, the total mass of the product are always equal to the total mass of the reactant, right? If it is not equal, then we can say it is a skeleton equation. If it is unbalanced equation, if that equation is not balanced, then we can say it is a skeleton equation. Okay, skeleton equation means unbalanced equation. So, the number of atoms on the reactant side are not equal to number of atoms on product side are called skeleton equation. Okay, skeleton equation means what? The number of atoms on the reactant side are not equal to the number of atoms on the product side. Then we can say it is a skeleton equation, right? So next one is, what is balanced equation? What is balanced equation? If the number of products, if the product side is equal to the reactant side, then we can say it is a balanced equation as per law of conservation of mass, isn't it? See the definition. A chemical equation in which the number of atoms of each element is equal on the reactant side and the product side is called a balanced equation. Balanced chemical equation. Okay, once again I repeat. A chemical equation in which the number of atoms of each element, okay, is equal on the reactant side and the product side is called the balanced chemical equation. Understood, children? So these definitions are very important. Got it? Right. Next is the limiting reagent. What is meant by limiting reagent? Limiting reagent means if the reaction is, if it is totally consumed, then we can say it is a limiting reagent, right? So limiting reagent means if the reaction is totally consumed, the chemical reaction, if it is totally consumed during reaction, then we can say it is a limiting reagent. See the definition. Limiting reagent is defined as the amount of product obtained is determined by the amount of the reactant that is completely consumed. This line is very important. Okay, if it is completely consumed in the reaction, then this reactant is called the limiting reagent. I repeat again, the amount of product obtained is determined by the amount of the reactant that is completely consumed in the reaction is called the limiting reagent. Okay, so look at the diagram. So this reaction happens before the chemical reaction has started. Okay, so this one before the chemical reaction has started. This diagram mentions once the reaction is completed. Okay, once the reaction is completed, then reaction takes place like this, right? So this mentions before reaction has started. This one after the completion of the reaction, right? So limiting reagent means the reactant that is completely consumed in the reaction is known as the limiting reagent, right? Next we can move to concentration terms. Okay, these terms are very important. First let us see about molarity. Molarity mentions the word, that is we have to use the capital M. Okay, for molarity you have to use capital M. Molarity is defined as the number of moles of a solute. Okay, number of moles of the solute dissolved in 1 liter. 1 liter means 1000 ml. Yes, 1000 ml of the solution. Molarity is defined as the number of moles of solute when it is dissolved in 1 liter, that is 1000 ml of the solution. Then we can say it is a molarity, right? To calculate the molarity of the solution, molarity of the solution is equal to number of moles of solute divided by mass of solvent in liter. Okay, molarity divided by mass of solvent in 1000 ml or otherwise 1 liter. Okay. This formula we have to use to calculate the molarity of the solution. Right. So next one, molarity. Molarity means it mentions small letter. We have to mention it in small letter. For molarity only we have to use the capital M. For molarity we should use the small m. Okay. Next, molarity is defined as number of moles of a solute. Number of moles of a solute dissolved in 1000 gram of a solvent. Okay. Dissolved in 1000 gram means it mentions 1 kg of a solvent. So molarity is defined as the number of moles of a solute dissolved in 1000 gram or 1 kg of a solvent. So to calculate the molarity of a solution, we have to use this formula, right? What is that? Molarity is equal to number of moles of solute divided by mass of solvent in gram into 1000. This 1000 you have to put here. Okay. Here there is no place. That's what I have written here. So to calculate the molarity of a solution, number of moles of a solute divided by mass of solvent in gram into 1000. Right. Third one is about mole fraction. Okay, mole fraction is represented by the letter X. So mole fraction is defined as the ratio of number of moles of the solute. Mole fraction is represented by the letter X. It is defined as ratio of number of moles of the solute or solvent. Whether it is solute or solvent, if it is present in the solution and the total number of moles present in the solution. Okay, total number of moles present in the solution. I repeat the mole fraction again. Mole fraction is represented by the letter X. It is defined as the ratio of the number of moles of solute or solvent present in a solution and the total number of moles present in the solution is known as mole fraction. Right? So to calculate the mole fraction, we have to use this formula. Moles of solute plus moles of solvent gives the mole fraction. Moles of solute plus moles of solvent is equal to mole fraction.